Hello everyone, so today we're doing 26.4, the dangers of radioactivity. Got some fairly horrible images here, so I just talk you through them and talk about why we need to protect against ionising radiation. So this first person here, his name is Alexander Litvinenko, and he was accused by the Russian government of being a spy, and they poisoned him with a radioactive alpha emitter in a tea. He didn't know, and then obviously because alpha is not very penetrating, it couldn't get outside his body. So a few weeks later he died. Basically, got major organ failure of every organ in his body. It was an incredibly painful way to die. This lady here has had some radiotherapy. So a bit like UV causes skin burns, obviously gamma radiation can cause burns as well. So this lady's had radiotherapy, but the machine is actually, the radiation from the machine has burnt her skin. Obviously, the benefits of having radiotherapy have outweighed the risks, and I don't think this happens with everybody. She's had a particularly bad reaction. But obviously, it is ionising radiation. It can cause damage. This image was taken from a film called The Hills Have Eyes, which is a particularly horrible film if you want to watch it. It's good, but it's horrible. And it centres around a family who live in the desert in America, where they did nuclear testing in the 1950s. And as a result of the nuclear testing, a lot of the family's offspring become deformed, and they're not very nice. So, yeah, the hills have eyes. And then this image shows some of the children who were born after the Chernobyl incident. The radiation emitted by the Chernobyl explosion caused defects in children born afterwards, where the sex cells of the parents were damaged. So you can see here one of them has a sore eye, and then this one, or a missing eye even maybe. We've got some elephantitis here, and then deformed limbs of the children too. So yeah, so not very nice, and why we need to protect ourselves against ionising radiation. So you need to be able to explain why ionising radiation is dangerous, state the factors that determine whether alpha, beta or gamma are the most dangerous, and discuss how exposure to ionising radiation can be reduced. So the hazards. You need to sort of know this answer word by word, but it's quite simple because you're at GCSE. So ionising radiation can destroy the cell membranes, which causes cell to die. It can also damage the DNA directly or indirectly by creating free radical ions, which react with vital molecules. Basically, it reacts with the DNA molecules. That causes a disruption to the normal cell division, and the nuclei become damaged. The damages to the DNA may cause cells to divide and grow uncontrollably, which can cause cause a tumour, which then can be cancerous. And damaged DNA in a sex cell may cause mutation, which can be passed on to future generations, which I just spoke about with Chernobyl. So it's really important that people that work with radiation all the time actually have some radiation monitoring. So anyone working with radiation has to wear a special badge. It's a film badge, and they wear it for the duration of the time that they are working within the area that the radiation is. So the badge has a film in it, and it's developed, and the amount of exposures to different types of ionising radiation can be estimated from the blackening of the film. If the badge is overexposed, the wearer can no longer work with the equipment or in the area that they were working with. And then the dose they received is the energy per unit mass of matter. So let's say you've got an adult and a child. Obviously the child won't be working, but for argument's sake, in the same area, and they both get a radiation dose. Because the child is smaller, their dose will be bigger because they are receiving the same amount of energy as the adult, but their mass is smaller. So it can have a bigger effect. So here's a picture of the badge, and you've got your different filters here that are different thicknesses, and then you have some different metals inside it to try and absorb the radiation to figure out which one it is. So around us all the time we have background radiation. We have evolved with this background radiation, and so we're used to it. And it doesn't really affect us too much, although some of these have been increasing recently. So by far the biggest amount of background radiation we get is air. It's 800 millisieverts, okay? We then have medical, 500 millisieverts, going then in the ground. So medical would be things like people having PET scans and things. We then have ground and building. So if it's in the air, it's in the ground. And if it's in the ground, we dig it up and we use it to make buildings. So it's in buildings. And again, in food and drink. So if it's in ground, then it grows in the food, and then we eat the food, etc., etc. Cosmic rays. So that's radiation from the sun. So it's gamma radiation from the sun. This has increased a lot recently due to more air travel. So people are getting a greater amount of cosmic rays than they used to for air travel. Although here, I put air travel separately here, I didn't realise. But that would be part of the cosmic rays section, and this would be on the increase. And then you've got two here, nuclear weapons and nuclear power. Because that industry is so well regulated, we get very little radiation from nuclear weapons and nuclear power, but obviously that has increased since the development of nuclear weapons and nuclear power. So how do we go about their safe use? The storage, disposable of radioactive substances must be carried out in accordance with specific regulation. So for storage, lead-lined containers are kept under lock and key, and a record must be kept. The container must be thick enough to reduce gamma radiation to about background levels. So that would include in school, when we have our radiation sources, we have to keep them under these guidelines. When they're in use, no source should come in contact with the user. So for solid sources, they're transferred using tools. We have to ensure the tools are kept as far away from the user as possible. So we would use tongs. That's due to the inverse square law. And if we use an alpha and beta, then we can keep students and the users out of the range of those, because their range is not as large as gamma. We use solid sources in school, but we don't use liquid, gas and powder sources because they're much, much harder to control. They have to be kept in sealed containers to ensure the gas and powder cannot be breathed in and the liquid cannot be splashed on the skin or drunk. And then the sources must not be used for longer than necessary. If the longer the exposure, the greater the dose. And obviously some users are not allowed to use this, so we wouldn't use them around pregnant women. And when I was pregnant with my daughter, I wasn't able to show how we use the radioactive sources when I was at school. I had to get another teacher to do it. That's because of the sex cells. Those sex cells can be damaged, and that can then lead to deformities in the child. Or if that would be someone who was not pregnant. If they were pregnant and the fetus is just developing, then that growth of cells can be disrupted by the radiation. Okay, so that's the end of the show. I'd like you to just take notes on this, but then for the actual task, I'm going to set you an exam question to do with count rates, which was part of what we did last lesson, but it's an actual exam question. So I want you to have a really, really good go at that. Can you make sure that you upload an image of your answers to 26.3 as well as part of the task? Thank you. Bye.